Okay, so today it's a short lesson, but it's a powerful lesson in many ways. Um, your key terms expand. So if you have something raised to the second power or third power binomially, you're expanding it. That means you're multiplying it out. Pascal's triangle is a specific triangle of arrangement of numbers. This is Pascal's triangle, and yes, you have to fill in the blanks, and I already have the blanks already filled in over here on the side. Okay. You will be given on your test. That will be on the board as it stands now. Not with the things that we are going to be adding to it in just a couple of minutes. But as it stands up there now is what you are going to have on your test. Okay, you will also be available to you on the final exam. Strictly the numeric portion though, nothing else other than that. But we're going to add to it here in a minute. Pascal's triangle is named after Blaise Pascal, who came up with this concept and this idea. Pascal's triangle has a tremendous number of uses. It has a tremendous number of patterns within the triangle. We're only going to use it for one specific detail. Blaise Pascal, by the way, is considered the father of computer programming. He conceived of the concept of an electronic device that would work like a computer works, and wrote computer programs, or the logic basically behind computer programming, before there was electricity. It wasn't like computers existed and then somebody said how they're going to run them. No, this guy came up with the concept of, hey, sometime in the future, you're going to have a machine that's going to operate based on logic, on inputs, the way that a computer works. And he wrote what you would call pseudocode, because it wasn't an actual computer language, but it followed all the logic, if this, then that, and that kind of stuff. And he wrote those and came up with those concepts before there was electricity available, before electronics existed. People knew about electricity, but wasn't like they had microchips or even transistors or anything like that at the time he did this. Okay, he was also, his assistant, and yes, air quotes for assistant, was Ada Lovelace, who was actually probably did more work than he actually did. If you look up Ada Lovelace, it'll have her down as doing the same thing. He gets the credit because he's a guy. She's starting to get the credit because we're saying people are finally starting to realize that yes, women actually did a lot too. They just never got any credit for it. And she is highly recognized as his partner, if not his, I wouldn't say superior, but I would definitely say his partner. Pascal did a lot of other things other than this. This is just one of the biggest ones. There is what is now a dead computer language called Pascal. I actually learned how to program in Pascal, 20-odd some years ago. It's now a dead language. Nobody uses it for anything. But yeah. So it's a big deal. And this triangle has got some really powerful things. What we are going to use it for today is for expansion. Okay. So here's what we're going to do. Example number 1. Foil it out. So take x minus 1 cubed and foil it out. In other words, do x minus 1 times x minus 1 times x minus 1. Please take a minute and do that. Okay, so that was fun. Imagine if instead of cubed, you had to the 7th power or something else, and you had to expand it out. That'd be a real pain in the butt, because you'd have to take what you got times x minus 1 and take that answer times x minus 1 and take that answer times x minus 1. Be a real pain in the butt, right? Pascal's triangle gives you a shortcut. If you go back and look here, this gives you an idea. The first row is the 0 power row. It's called the 0 power row because this is what you get when you take a plus b, any binomial, to the 0 power. Because what is anything to the 0 power? It's 1. Okay. This is the first power row because if I take a plus b to the first power, I get 1a plus 1b. This is the second power row because this is the expansion of a plus b squared. Now, there's a pattern to this. There's a pattern to the numbers. I hope you see the pattern in the numbers, right? How do you get the next number? You take the two above and add it together. Take the two above and add it together. It's all ones down the edges. It goes 1, 2, 3, 4, 5, 6, 7 down here. And the same way down here. And there's patterns actually to the 1, 3, 6, 10, 15, 21. There's a pattern to those numbers as well. There's a pattern to this row. There's, anytime any row you pick up, there's a pattern in that row. Sometimes they're harder to find than others, but there is a pattern to every one of those. Okay. I believe these are the triangular numbers. I think these are the rectangular numbers, but I can't remember off the top of my head. Okay. But when you're doing expansion, you can cheat and use this to expand those. So this is the third power row because this is a plus b to the third power. Now, there's a pattern to my a's and b's. On this one here to the a plus b to the second power, I have a here, then I'm going to have a squared, ab, b squared. This one's cubed. So I'm going to have a cubed, a squared, and a. Going the other direction, I have b cubed, b squared, and b, whatever those numbers are, times the coefficient of the number that's in there in the triangle. I can do this for any power. That's what this expansion works as. So if I have a plus b to the fourth, I'm going to have coefficients of 1, 4, 6, 4, 1. My a's start here because it's the fourth power, a to the fourth, a cubed, a squared, a to the first. My b's work in the opposite direction. B to the fourth, b cubed, b squared, b to the first. So I can expand any binomial just using this. I don't have to multiply that same thing over and over and over by itself. That's what Pascal's triangle does for you. And it gives you that opportunity to not have to do all the hard labor. It only works if you have a binomial raised to a power, but you can do it for any power. All you have to do is just extend the triangle if you want to get past a certain level. Okay? So if we go back to our example here, I want to do x minus 1 cubed. What you want to do is you want to identify what your A term is and what your B term is to help it follow the pattern in the example. So my A term is what? X. What's my B term? -1. It's -1 on this. Watch your positives and negatives. So if I want to expand this out using Pascal's triangle, I go to the fourth row, which is actually the third power because it goes 0, 1, 2, 3. And I'll have 1 times whatever a cubed is, 2 times a squared times whatever b is, 3 times a times b squared, and 1 times b cubed. Let me do something here real quick. So, cubed, third power row. My coefficients are 1, 3, 3, 1. 1, 3, 3, 1. My A term is x. So I'm going to have x squared, x cubed, x squared, x to the first. And then no x's in the last term. And then when I do my b's, I'm going to have b cubed, b squared. I should have had a little more room. And then b to the first, and then no b in the first term. Now, this is not very pretty looking as it is right now, but it's very easy to clean up because that's what I want to do is I want to clean it up for my answer. So my first term in my expansion is 1x cubed. We don't write the 1, we just write x cubed. My second term, I have 3 times x squared times negative 1, negative 3x squared. My third term, 3 times x times negative 1 squared. Well, negative 1 squared is 1, so that's 3 times x times 1, which is 3x. And then my last term is 1 times negative 1 cubed. Well, negative 1 cubed is negative 1 times 1, so I end with a minus 1. That and this are the same thing, without having to multiply x minus 1 times x minus 1 and then do it again. Okay, does that make sense? Brooke Hopkins. I would suggest waiting until after we get done with this. Just wait until you're done. Okay? So let's do some more examples here, because that's the way you're going to pick this one up. Okay, so I want to do m plus 3 to the 4th power. Identify your a term. Okay. Guys, what's my a term in this one? M. What's my b term in this one? 3. What power am I doing? 4th power. So I come down to the 4th power row. My coefficients are 1, 4, 6, 4, 1. My coefficients are 1, 4, 6, 4, 1. That's what the numbers are in the 4th power row. Okay. Hardest part for kids to remember is it goes 0, 1, 2, 3, 4. But here's how you do it. Your exponent matches the second number. Cubed. First power row, this is squared, cubed, 4th, 5th power, 6th power, 7th power. Whatever you're expanding matches the second number. It's kind of nice that way. Makes it easier to remember which row goes to which. And then to get the numbers that filled in and behind it, you basically start with a to whatever power it is and then reduce the power by 1. So I'm going to start with a to the 1st power, which means, or to the 4th power, which means I have m to the 4th, m cubed, m squared, and m to the 1st, and no m in the last term. And then I go start at the the right-hand side and go in the opposite direction with my b's. B to the 4th, and then reducing it from there. So I have 3 to the 4th, 3 cubed, 3 squared, 3 to the 1st. And I'm going to grab my calculator, because the numbers on this can get big in a hurry. And although I can do 3 to the 4th in my head, 3 cubed times 4, I can do that too, but it's a lot more easier. Use this. Okay? So what's my answer? These are all just my individual terms. Now I need to simplify them down. Make it, get rid of any ones that are by themselves, square out any numbers, anything like that, right? So my first term, this is easy. It's m to the 4th. The other thing is easy. There's no negative here, so none of them are going to be negative. They're all going to be positive. Plus 4 times m cubed times 3, 12m cubed. 6 times m squared times 3 squared. 3 squared is 9. 9 times 6, 54 m squared. Okay. The next term, 4 times m times 3 cubed. Well, 3 cubed is 27. times 4 is 108. I get 108 m plus 3 to the 4th is 81. It sure beats doing m plus 3 times m plus 3 times m plus 3 times m plus 3. Like I said, you will have the triangle, you will have the number portion, you won't have the rest of it. Okay. So let's set up the next one. First question is, what's your A? It's m again. What's your B? -4. So I got a negative. I got to be careful with my negatives. And what power am I doing? I'm doing 5, so that means I go down here to the 6th row down. 1, 5, 10, 10, 5, 1. So my coefficients are 1, 5, 10, 10, 5, and 1. And I start filling in my A's and B's. So I have m to the 5th, m to the 4th, m cubed, m squared, and m. It's really easy. Start with the highest power in the front and work your way down one power on each. Do the reverse coming out the other direction with your B's. -4 to the 5th power, -4 to the 4th power, -4 cubed, -4 squared, and -4. And sorry, it's a little tight on space. And then you start simplifying each term. My first term is 1m to the 5th. So my first term is m to the 5th. Then I have 5m to the 4th times -4. Well, that's easy. -20m to the 4th. The next one is 10 times -4 squared. Well, -4 squared is positive 16 times 10. That's easy. Plus 160 m cubed. The next one is -4 cubed. 4 cubed is 64. -4 cubed is -64. Times 10 times m squared is -640 m squared. The next one is 5 times m times -4 to the 4th. And 4 to the 4th power is 256 times 5 is 1,280. And yeah, use your calculators, people. And because it's an even power, it's plus 1,280 m. And then I have -4 to the 5th power is -1,024. Use your calculators. Not too bad, right? Like I said, it sure beats taking multiplying it times itself 4 times. Okay. Next one's a little more complicated. What's my A? My A is 3y. My B is -2. My power is the 3rd power, so I go to the 3rd power row. It's nice, there's only 4 terms. 1, 3, 3, 1. So my coefficients are 1, 3, 3, and 1. And then I start filling in my A's and B's. It's cubed, so I have 3a cubed, 3y squared. I said 3a, I'm at 3y. and 3 y to the first. That's my a terms. My b term is -2. I do the same thing going the opposite direction. -2 cubed, -2 squared, and -2 to the first power. Now begins the fun. I got to cube them out, and square them out, and multiply them. Use your calculator if you can't do this, if you don't know the numbers or get them off the top of your head. Not a big deal. Okay? My first term, I take 3y and cube it, multiply it times 1. So 3 cubed is 27. So this is 27y cubed. The next one, I have -2 to the first, so it's going to be a minus. I have 3y squared, which is 9y, times 3. 3 times 9 is 27, times 2 gives me -54y squared. Once again, use your calculators to do the arithmetic. I'm okay with that. Next one, 3 times 3y times -2 squared. The only negative I have is squared, so it becomes positive, so this will be a plus. 3 times 3 is 9. 9 times 2 squared, 2 squared is 4. 9 times 4 is 36, so I have 36y. And then the last one's easy. I just take -2 and cube it, and I get -8. Follow the patterns, it's a piece of cake. Okay, last example before you get to do it on your own. My a term in this one is 2a. My b term in this one is 5. And I'm going to the 5th power. Ooh, I haven't done the 5th power yet. Ooh, I don't know my a's and b's. Actually, it's really easy to do that anyways. We can figure that out. But it's 1, 5, 5, 10, 5, 1. So to give myself some space, 1, 5, 10, 10, 5, and 1. Fill in your a's. Has a 5th power, so I start a to the 5th. So I have 2a to the 5th power, 2a to the 4th power, 2a cubed, 2a squared, and 2a. Then I fill in my b's, working the opposite direction. This is 5 to the 5th power, 5 to the 4th power, 5 cubed, 5 squared, 5 to the first, and no 5 in the first term. Fifth power, down 1 power each time for A. 5th power for B, down each time, moving from right to left on the B's. And then simplify it out. So 1 times 2a to the 5th. Well, 2 to the 5th, 2, 4, 8, 16, 32. 32a to the 5th power. I'm busting out my calculator for the next one. 2 to the 4th, 2, 4, 8, 16. That's 16 times 5 times 5, so 25 times 16. Get 400 a to the 4th plus 2a cubed. 2 cubed is 8 times 5 squared, which is 25, times 10. So 10 times 8 times 25 is 2,000 a cubed plus 10 times 2 times 5 cubed. 5 cubed is 125 times 20. 2 times 10 is 2,500 a squared plus, and it's kind of, I know it's a little tight in here, 5 times 2 times 5 to the 4th. Well, 5 times 5 to the 4th is 5 to the 5th, right? 5 to the 5th power times 2. 6,250 A's. And then I have 5 to the 5th, which is 3,125. Use your calculators to do the multiplication in powers, because they can get big and ugly in a hurry. Okay, use your calculators. I got a box full over there, borrow one. Okay. Questions so far? Okay, whose turn is it now? Yours. Do them. Okay, let's go ahead and do this. So the first one, your A term is X, and your B term is 2. That's nice. To the 4th power, so I go to the 4th power row, which is 1, 4, 6, 4, 1. So I have 1, 4, 6, 4, and 1. And I put in my A's, x to the 4th, x cubed, x squared, x to the 1st. Put in my B's, 2 to the 4th, 2 cubed, 2 squared, 2 to the 1st. And then I multiply things out. 1x to the 4th gives me x to the 4th. 4x cubed times 2 gives me 8x cubed. 2 squared is 4. 4 times 6 gives me 24x squared. 2 cubed is 8. 8 times 4 is 32. X plus 2 to the 4th is 16. Next one's even easier, but you do have to watch your negatives and positives. My A term is Y. My B term is -3. Third row down is 1, 3, 3, 1, or sorry, third power row, 1, 3, 3, 1. So my A term is Y, so I have Y cubed, Y squared, Y to the 1st. And then my B term is -3, so I have -3 cubed, -3 squared, -3 to the 1st power. And then I multiply it out. So I have Y cubed minus 9Y squared plus 27Y minus 27. Questions on that one? Not too tough. Next one's a little more complicated, but it's not bad. Your A term is 2V. Your B term is -1. It's nice when I have a 1 in there. It's the 4th power, so I go to the 4th power row. 1, 4, 6, 4, 1. 1, 4, 6, 4, and 1. Do my A's, 2V to the 4th, 2V cubed, 2V squared, 2V to the 1st. Do my B's, -1 to the 4th, -1 cubed, -1 squared, -1 to the 1st. So I have my coefficients, my A's and my B's. Simplify each term. 2 to the 4th, 2, 4, 8, 16. So I have 16v to the 4th. And then I have a minus 1. So I have minus v cubed. 2v cubed is 8v cubed. 2 cubed is 8. 8 times 4, 32v cubed. I have negative 1 squared, so it's going to be plus. 2 squared is 4. 4 times 6 is 24v squared. The next one, I have negative 1 cubed, so it's going to be a minus. 2 times 4 is 8, so it's minus 8v. And the last one is negative 1 to the 4th power, which is positive 1, plus 1. And then last but not least, my A term is 3m. My B term is 2. The numbers on this are going to get large. It's the 5th power. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, and 1. Start with my A's. 3m to the 5th. 3m to the 4th. 3m cubed. 3m squared, and 3m, and then do my b's. 2 to the 5th, 2 to the 4th, 2 cubed, 2 squared, 2 to the 1st. And I am busting out my calculator on this one. Okay, so my first term, 3 to the 4th, which is 81, times 2 times 5, that's 810. So I have 810 m. Oh, sorry, my bad. That's the second term. First term, 3 to the 5th. Oop. 3 to the 5th power is 243. M to the 5th, plus 3 to the 4th power is 81. 5 times 2 is 10. That's 810 m to the 4th. And then I have 3 cubed, which is 27, times 2 squared, which is 4, times 10, which gives me 1080 m cubed, plus 3 squared is 9, 2 cubed is 8, 9 times 8 is 72, times 10, 720 m squared. 2 to the 4th is 16, 16 times 5 is 80, 80 times 3 is 240 m, and then 2 to the 5th is 32. Ooh, pretty good. I did a lot of that in my head. Yes, I am proud of myself. Questions? Okay. So here's the nice thing about Pascal's triangle. Let's say I don't want the whole thing. Let's say I don't want every single part of the expanded polynomial. I only want part of it. I want one particular term. Pascal's triangle lets me find that one term without finding everything else. I don't have to find everything else. I just can find that term, that particular term. Still need to do the same setup. I still need to figure out what A is. A in this case is 2W. B in this case is -3. And now what I need to do is I need to figure out my expansion. And I don't have to do the whole thing, I just need to find one term. So I'm looking for the third term for the sixth power. So I go to my sixth power row, 0, 1, 2, 3, 4, 5, 6, and go to my third term in, 1, 2, 3, my coefficient is going to be 15. Third number in on the sixth power row, which is actually the seventh row down, is 15. So that's my coefficient out in front. Now I need to figure out my A to what power and B to what power. That's actually really easy to do. If you look at the triangle on the A's and B's I already have in there, what does each term, what do the exponents add up to on each term? In this first one here, I have a 1 and a 1. What's first power? This one here, I have A squared, A to the first, B to the first. What do the exponents add up to? 2. What do my exponents add up to? 2. In my third power row, what do my exponents add up to? Please, people, what do my exponents add up to? What do they add up to here? 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 Here, 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 4, right? So what are they going to add up to on this one? They're going to add up to 6. So if I figure out, well, one I missed, I can do the other one. So I'm going to have A to some power. My A is 2W. And I'm going to have B, which is -3, to some power as well. And I got to figure out those powers. Well, that's easy. Okay. What is my power that I have originally? It's 6. I want to go the third term over. So the first term is going to have a power of 6. Second term is going to have a power of, actually, the second term is going to have a power of 5. Third term is going to have a power of 4. Start with 6 in the first term, 5 in the second term, 4 in the third term. So my A is to the fourth power, which means my B is going to be to the second power because those exponents have to add up to 6. There we go. And now do the arithmetic on the numbers. So I have 15 times 2 to the fourth, which is 16, times -3 squared, which is 9. And so I get 2,160 W to the fourth. So I want to do the same thing on this one. So I want the fifth term in x minus 4 to the seventh power. Seventh power row, this one here, fifth term over. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. I have a coefficient of 35. Just get that from the triangle. And then I'm going to have A, which is x to some power, and B, which is -4 to some power. And I got to figure out the powers. So what do I start with? I start with 7. And I want the fifth term. Well, I count down. 1, 2, 3, 4, 5. So I'm going to have third term. Third power on there. My first term is going to be the third power. Which means my other term is going to be the what power? Fourth power, because I have to add up to 7. And then you use your calculator to take 4 to the fourth power and multiply that times 35, because I'm not doing that in my head. $8,960 x cubed. Don't have to do the whole thing to get one term. Your turn. Do those two. This shouldn't take too long. So the first one, fifth power row, I want the fourth term. So I go to my fifth power row and go 4 over 1, 2, 3, 4. So I have a coefficient of 10. And then my A term is y. And my B term is -2, which makes it actually really easy. So I have fifth power row, I want the fourth term. First term, second term, third term, fourth term. I'm going to have a power of 2 on my A. So I start out, first term has the full power, second one has 1 less power, third term has 1 less power, fourth term has 1 less than that. So I'm going to have my first term is going to be squared. So I have A squared. And they need to add up to 5, so that means I have 2 cubed. -2 cubed. -2 cubed is -8. -8 times 10 is -80. So this one's -80 y squared. Okay. Another example, second term in the sixth power row. So go to the sixth power row. Second term has a coefficient of 6. So I have 6. Then I have A is 3x. Oh, and this is really nice. B is first power. So the second term in the sixth power row, so I have 6 in my first term, take away 1, I have 5. So I have 3x to the fifth power and -1 to the first power. That makes it really nice. The hardest part is 3 to the fifth. 3 to the fifth. And I get 243 times 6, which means I get 1458 x to the fifth. That's my answer. It is one of the nice things. Sometimes you don't want the whole thing, you just want one part of it. Let's let you get that one part without having to find everything. Okay.